open up your books, turn it to page 545. Right here, page 545. It says Properties of Similar Polygons, Lesson 4. And actually, this entire front page here, I don't really like, so let's speed things up and turn the page. All right, here we go. So here we go, similar polygons. Two important things with similar figures. If two polygons are similar, we've talked about this in class, that means their corresponding angles are congruent. So angles are congruent, meaning the angles are the same. And our picture here shows that angle A has the one arc, is congruent to angle X with one arc. Angle B has two arcs, is congruent to angle Y with two arcs. Angle C has three arcs, congruent to angle Z with three arcs. So all the angles are the same. That has to happen for them to be similar. The second thing that has to happen is the measures of the corresponding sides are proportional. Okay? So the sides need to be proportional. And what that means basically is what we talked about this last week when we talked about scale factor or dilation or the K, that all of the sides need to expand or dilate either by expanding or shrinking at the same rate. When they expand or shrink at the same rate, that's what we call proportional. And that's what we're going to look at today. Okay, so vocab word is similar polygons. Polygons that have the same shape are called similar polygons. Remember, angles mean the shape stays the same if the angles are the same, okay? But our side lengths can be different. Number one here, it says determine whether rectangle HJKL is similar to rectangle MNPQ. And here's basically what it says. It says first check the corresponding angles. So we need to look at all of our angles. Do they match up? Well, everything's 90 degrees, so it matches up. And then it says, since the two polygons are rectangles, all the angles are the same. Now we can check the corresponding sides and see if they are proportional. Okay? So we're going to check. Well, we see first we have HJ, which is 7. And then we have the matching side over here, MN, that's 10. That's where we got the 7 and 10. Then we're going to check this side here. We're going to check side JK is 3. And then side that matches up with it is NP, which is 6. Now here's the thing. Right now, I have two different fractions. If it is similar, if the two shapes are similar, meaning proportional, these fractions should simplify to the same amount. Or if you divide, you should get the same amount. Now right now you might be able to tell that 7 over 10 and 1/2 do not simplify to the same amount. You may know that off the top of your head, and so you know right away, since 7 over 10 and 1/2 are not equivalent, the rectangles are not similar. Or if you aren't great at simplifying, you can also simply divide 7 divided by 10, because that's all a fraction is division, and you get a decimal of 0.7. So right by this you can write 0.7, and then 1 divided by 2 is 0.5. So by that I'm going to write 0.5. They should be the same decimal. If they're the same decimal, yes, they're proportional, they're similar. But here it's different decimals, just like it's different fractions, so we know they're not. I'm actually going to turn the page. So I'm going to turn the page to the guided practice. And I want to look here at number 2. So directions are the same. Determine whether each pair of polygons is similar, and then be able to explain. Well, what we need to do here is take the sides, and we need to take the matching sides. We need to make sure angle 1, angle 2, angle 3, angle 4, all of the angles are the same, so we know right there, okay, part 1's done, angles are the same. Now it's part 2, are they proportional? Meaning if I take matching sides, we should get the same fraction. So the first one I'm going to take is, I'll just take this side right here that's 8. Now what's the side on the other polygon that matches up with 8? The line between the 1 arc and 2 arc is up there. The 1 arc to the 2 arc is right there. That's 6. So 8 over 6 is my first fraction. Okay? And 8 over 6, I think, okay, you know, what goes into both of those? If I want to simplify, I go, okay, 2 goes into both of those. 8 4 times that there. So my next fraction should also simplify to 4/3 if they're truly proportional. So now I look at my next one. So there's 1. My next one, I'll take the 18. So I'll take the 18. Now I took this one first with the 8, so I got to keep using this one first. I have 18 over the matching side, 3 to 4. 3 to 4 is 13.5. Now that one's tricky to use, 13.5. So this may be a situation where it's best to use a decimal. So I need to make my first one a decimal, where I had 4. I had 4 divided by 3, and that decimal is 1.3 repeating. Then I can change this one to decimal, 18 divided by 13.5. That also gets me 1.3 repeating. So right there, I have two 1.3 repeatings, all right? But all of the sides need to be proportional, so I need to check the other side. Well, now I look for what else matches up. Well, right here I have an 8, right? Between the 2 and the 3 arc. So between the 2 and the 3 arc, here I have a 6. Well, I've already compared 8 and 6, so I don't need to do it again. Those sides are the same. So over here, just as a placeholder, so you know you did all 4 sides, make another 1.3 so you know, okay, I checked that one as well. Now, I'm going to check the last side. This side's 10. I haven't done this one yet, so I need room. That one is a 10 over. What's the side that matches up between the 1 arc and the 4 arc? 1 arc and 4 arc. 4 arc is 7.5. So I take my calculator. I do 10 divided by 7.5. And I get 1.3 repeating again. Notice all 4 of those are the same. So when it asks, determine if each polygon is similar, I would put yes. They're similar because I would just put all fractions are the same. And then you also have your work right there to back it up. Okay? Now, going back here, once again, why weren't these ones similar? Because the fractions or the decimals, they were not all the same. All right? Now, that's how you determine if something is similar or proportional. So here we have scale factor. Scale factor is kind of like the K. Scale factor is what the ratio is. It's basically like a fraction or proportion. So here on example 2, it says quadrilateral WXYZ is similar to quadrilateral ABCD. You're not having to determine. There's no determine here. It's telling you, hey, these are similar. So you don't need to worry about checking for that. And I need to minimize this right here. Miss Neely always has her stuff pop up in the middle of the lesson. Okay, minimize. There we go. Okay, so it already tells us that they are similar, so we don't have to determine. Now, what it's asking us to do is describe the transformation to get one on top of the other. Well, obviously there's a dilation. It needs to enlarge. And then a translation, slide it over. Okay, no big deal there. Then part B is find the missing measure. So what side's missing? Side M right there. I need to find side M. Well, it shows you 2 different methods to find side M. Method 1, me and Miss Neely are not big fans of, so you can just cross that one out. It's a little bit too complicated for what we want to do. Here's method 2. This is the one that is typically used. What you do first is I look at XY. This is my missing side. So I make the line segment XY as a fraction. Okay, there's my XY. Then I take the matching side that matches XY from the other one, which is BC right here. So I put BC underneath because BC right here matches up. Then I need to pick a different side. I need to say equals. Well, I now need over here, this is the one, of course, I don't know. So I need to find one on the other, I need to find pairs that I know for sure equal each other. So I'm just going to take, for example, here I have YZ, I know is 15. Now this is on the bigger one to the right. The bigger one on the right was on top, so it has to stay on top. So here I'm going to have YZ over the one that matches up with it, DC. Then that's step 1. Step 2 is I plug in my numbers. XY is M, unknown. I know that BC that matches up with it is 12. Equals. Well, what's YZ? 15. Over, and you should be writing all of this down, YZ I know is equal to the CD right here, which is 10. Okay? So now, this right here, when you have two fractions equal to each other and you're only missing one number, through cross multiplication, I know that M times N should equal the other cross multiplication, 12 times 5. Sorry, 12 times 15. So I just multiply. 12 times 15 is 180 equals whatever M times N is. Well, how do I get rid of multiplying by 10? I divide by 10. What I do to one side, I have to do to the other. And then M should equal 18. Now, a shortcut to that is when you have these fractions here, it's called cross multiplying and dividing by what's left. Notice my M is what I don't know, so I leave it. The two diagonal numbers that I do know, 12 and 15, I multiply them. Notice I multiplied 12 times 15. Then I just divide by what's left. So if you see this, you know the diagonals, numbers you know, multiply. Then the number that's left, you'd simply divide by. Because notice I ended up dividing by 10. So that's a little shortcut there. You can know to multiply, cross multiply, divide by what's left. Anytime you have a problem like this, where two fractions are equal to each other and one thing is unknown. Now let's take a look at our last example right here. And it says, find the missing measures. So first we want to find WZ. All right. So to find WZ, that's this side right here. I'm going to label that side, I'll give it a letter. I'll just call it, let's see, I'll call it, let's see what numbers aren't used. I'll just call it L. So if we want to find WZL, I'm going to put it first. So I have my L over what side matches up with L on the other one. Well, there's 1 to the 4, 1 to the 4, that's 13. Equals, now I need to pick something from the other shape that I know for sure. So things I know from the other shape are right here. Now L was on top, so I need the number from this figure on top, which is 15, over the one that matches up, 10. So if I then set up my equation, I know that L times 10 will equal the other two multiplied, 13 times 15. So I take my calculator, I do 13 times 15, I get 195, equals L times 10. How do I get rid of multiply by 10? I divide by 10. So I divide that by 10, I get 19.5. So I know L equals 19.5. And that's how you actually find a missing side. All right, come to class with any questions you have tomorrow.